Welcome to this explainer. Okay, let's just dive right into it. Imagine, if you will, a chaotic underworld. A dark, tangled labyrinth of overlapping permissions, forgotten pathways, and lurking dangers. And no, I'm not talking about some fantasy novel. I'm talking about a messy, legacy cloud environment. To bring order to all of that chaos, you really need a powerful entity, but one that is strictly bound by unbreakable rules. So today, we're going to explore exactly how to tame this legacy underworld by auditing Azure, and we'll be doing it using Anthropic's Claude on Amazon Bedrock.
Picture this scenario for a second. What if you suddenly inherited an Azure environment that's been running largely unchecked for 8 straight years? Try to visualize that monstrous tangle. You're looking at hundreds of network security groups, or NSGs. You've got ancient firewall rules just layered on top of each other, and public IPs floating around that literally nobody remembers provisioning. Well, the core problem here actually isn't collecting the data. The real problem is understanding that data before it turns into a critical breach.
So here is our roadmap for taming the chaos today. 1. The legacy Azure nightmare. 2. The read-only audit architecture. 3. Normalizing the evidence bundle. 4. AI reasoning and tool use. And finally, 5. Enforcing AI security guardrails. Let's get into it.
Starting with Section 1, the legacy Azure nightmare.
The grim reality of legacy network security is that we aren't just dealing with one isolated issue, right? We're dealing with a sprawling mess. You've got internet exposure where broad 0000/0 rules are just allowing anyone access to sensitive admin ports. Then you have rule sprawl, duplicate, shadowed, or completely obsolete rules. Weak network segmentation means your app, database, and management networks are basically all just mingling together. Then there's public IP drift, where resources stay internet reachable long after the business need has completely vanished. Add in broad any-to-any patterns, stale exceptions that were supposed to be temporary, and massive telemetry gaps. Traditional scripts really just struggle to fully comprehend this tangled web of context.
Before we go any further, let's inject a pragmatic reality check for all the Azure architects out there. While NSGs filter inbound and outbound traffic, Microsoft's documentation currently states that NSG flow logs are retiring on September 30, 2027. So as we're building these auditing tools today, we absolutely must plan for virtual network flow logs as our long-term target, not just rely on those legacy NSG flow logs. It's totally crucial to keep your eyes on the horizon here.
All right, Section 2, the read-only audit architecture.
Let's walk through our step-by-step pipeline journey. It starts with Step 1, collecting and normalizing the data. Then, Step 2, we run deterministic checks. Those are your hard, fast rules. Third, we bring in Claude AI for the complex analysis. And finally, Step 4, human approval. I really want you to remember this core mantra throughout our entire explainer today. Evidence first, AI second, human approval always. The crucial point here is this concept of separation of duties. I actually love to call this the glass room concept. Think of the AI like a tremendously powerful reaper, but one that is permanently trapped behind a pane of impenetrable glass. Azure supplies the evidence, and Claude sits safely inside its glass room and reasons over the sins of the network. It can analyze the data perfectly, sure, but it cannot swing its scythe. It literally cannot directly modify NSGs, routes, firewalls, or VMs.
Our primary goal is turning all this messy legacy data into a structured, evidence-based audit, completely without giving the model unrestricted access. Safety and structure, those are our guiding principles. We are leveraging the immense reasoning power of the AI, for sure, but we are keeping it completely, unequivocally read-only.
Moving on to Section 3, normalizing the evidence bundle. Now, we absolutely do not just dump a massive, raw Azure subscription file right into the AI's lap. That's just a recipe for confusion and hallucination. Instead, we transform these heterogeneous, chaotic Azure objects into a consistent, compact, security-oriented JSON schema. Basically, we condense the reality of the network into a neat, standardized package, an evidence bundle that the AI can easily digest and understand.
But before that bundle goes anywhere, we have a vital step, redaction. You must scrub the evidence bundle of any sensitive secrets, tokens, passwords, private keys, or just unnecessary personal data. If it's not strictly needed to analyze network routing and permissions, it gets stripped out. This sanitization has to happen before a single byte of data ever crosses over into Amazon Bedrock.
Section 4, AI reasoning and tool use.
It's super important to understand the division of labor here. On one side, we have our deterministic engine. This is your traditional, rigid, rule-based scripting. It is absolutely perfect for catching known policy violations, like a blatantly open RDP port. But on the other side, we have Claude AI. Claude steps in to handle the really messy reasoning, the complex relationships between subnets, the context of the business application, and figuring out the actual prioritization of the risks.
Because at the end of the day, AI complements. It does not replace our conventional controls. We always run those deterministic checks first. We let the standard scripts catch the low-hanging fruit and the obvious violations. It's only after that we engage the AI, letting Claude do what it does best, untangle those complicated relationships that standard scripts are just totally blind to.
So how do we keep Claude focused? Strict prompt engineering. Take our system prompt, for example. We tell it, audit the Azure evidence below. Do not invent facts. Only make a finding when the evidence supports it. We are explicitly binding the AI to that evidence bundle we created. We're commanding it to act strictly as an auditor. It is completely forbidden from hallucinating resources, IPs, or traffic events that aren't sitting right there in the JSON.
We also don't let Claude just invent a magical risk score based on its feelings. We define the rules of the underworld that it has to follow. We provide a strict mathematical weighting formula. For instance, internet exposure might be worth up to 35 points, a sensitive admin port up to 25, observed traffic up to 20, and so on. We define the scoring model, and Claude simply executes that logic against the evidence. This is what keeps our audits consistent and comparable over time.
Let's look at how this builds into a real scenario. Imagine a legacy web VM with a public IP, an NSG allowing inbound TCP on port 3389, and flow telemetry proving repeated RDP connections. Claude receives this normalized evidence, correlates the rule with the public IP and the flow summary, and generates a structured critical finding. It connects the dots perfectly, explaining exactly why this is a high risk, all based purely on the evidence it was provided.
Which brings us to Section 5, enforcing AI security guardrails.
When we actually allow Claude to use tools to ask for more specific evidence, we have to apply extreme caution. Every single tool must be read-only, parameter-validated, rate-limited, logged, and explicitly allow-listed. Claude must politely ask our application for specific data, like requesting get_NSG rules for specific ID. It does not get to run arbitrary Azure CLI commands under any circumstances.
In fact, let's talk about the cardinal sins of AI integration for a moment. What not to do. Never, ever give the AI a tenant-wide admin credential. Never expose an unrestricted shell. Absolutely no direct deletion of NSGs or public IPs by the model. Do not ever treat a model-generated assumption as hard evidence. And honestly, most importantly, do not blindly apply an AI's remediation plan directly to your production network. The consequences of giving the AI too much agency could be quite literally catastrophic.
To further lock things down, we rely heavily on Amazon Bedrock's structured outputs. Look, for a security workflow, relying on free-form AI pros is just way too fragile. Downstream systems need predictability. By enforcing a JSON schema, we ensure the AI returns its findings in a strict, predictable format, giving us severity, ID, the evidence list, and its rationale every single time.
And just a quick practical note for the engineers who are actually deploying this, Amazon Bedrock features and model availability update pretty frequently. Always verify the current regional availability, model access, and API support in your specific AWS region before you go baking this architecture into your production environments.
So, what should you really take away from all this? The true power here isn't just mindlessly slapping an AI onto a cloud environment. It's about fundamentally shifting your mindset. Instead of asking, where can I add AI to my workflow? Ask yourself, what structured evidence can I safely give AI so it can help me understand risk faster? It all comes right back to our core mantra. Evidence first, AI second, human approval always. So tell me, what legacy underworld are you going to tame first?